So here we have an Ender 3 delivered to my house just today. I've gathered up a lot of my favorite tools for working 3D printers, whether it's just little bit kits like this, small little clippers, a scissor, and I guess I won't need this today. But without any further ado, let's just get started. Dig right in. So in the past, I've owned a CR10. It's very, very similar to this. I think the CR10 came out before the Ender 3 did, but the Ender 3 I noticed took a lot of the same design choices that the CR10 did, which is great for a cheap unit like this one that's definitely aimed for more of the beginner market. So it's a box in a box in classic style. I apologize if I sweat. This room doesn't have air conditioning. It's pretty warm and humid, and any fans really kind of ruin the audio quality. So, pretty thankful that no big dents are in the box here. But I generally enjoyed my experience with the CR10. I kind of surpassed it, I guess would be the word that I'd use. I wanted to do more advanced things, and so that's why I eventually traded it actually for a drone, of all things, and bought a Reliability. So, top, we have some ESD foam that's actually more or less custom fit, I guess, just some blocks glued on, and the main board. So, one good thing compared to the CR10, this definitely has a much better instruction guide. So it's going to tell me to Ender 3 Pro. Okay, good. And first instruction is to not script or voltage. New revisions may not be listed. Please plug the power cord into 3-hole. Detailed instructions that are for use are available on the card. Okay, cool. We could choose to not read the instructions like everyone, but we're going to read the instructions today. So, first, looks like we have a list of all the mechanical parts, including the belts, and next is a list of all the aluminum sections, and then third, the fasteners, and fourth, the tools. So it looks like it comes with some Allen keys, snippers, a scraper, extra nozzle looks like. I have some extras for my CR10 still floating around, but eventually I will replace the hot end on this one with a full all-metal E3D V6 because it's just the gold standard. They're unbeatable. I love them. Alright, so step one, we're going to find some M5 screws and a washer, and we're going to attach the two tall pieces to the base. So let's move the box over a little bit so we can have a work area, and we'll grab it from there. So everything seems packaged really well. It's all custom. It's all custom cut foam. It's not wrapped in anything goofy and just kind of thrown in the box. Everything has a place and everything is in its place. So very different than my CR10. I got a CR10, I want to say 2 years ago now. And the presentation was significantly worse in terms of how it was packaged. But this seems like they really figured it out. Great. Just grabbed everything like a moron. Okay. So I'm gonna unwrap all the cables here from the base. Looks like just stuck in some cables here. So taking a look at it right now, I really like this this bed holder here. So it's a nice injection molded piece that makes sure that there isn't much strain put on this connector. It's really common for them to break, and I really appreciate that everything is bundled away. It's put through the aluminum extrusion at the bottom here, and the cable management is pretty well done. Very happy to see that. Belts are loose from the factory, but that's actually a good thing. Prevents them from being overstretched by movement and shipment. So number 15 and number 16 are the two items that I'm supposed to place on top. So here it is. So it doesn't look like they're numbered. I'm going to assume that they are this pair. So they're definitely not this pair. The picture shows two 10 by 20 aluminum extrusions, not the 10 by 10 pair that I have. And when I looked in the thing, I added some. And when I looked in the box, I found that the bed leveling wheel had gone out of place. But it looks like in order to get to the rest of the frame, you need to move this foam piece here. Well, to kind of move some of this stuff around out of the way. So there aren't too many 3D printed parts that I can see so far, which is, you know, it's not unusual to see on 3D printers. Like, you know, it's kind of cool to be able to say that, you know, the printer has been improved by 3D printing, right? I mean, that's what I'm going to do. I'm going to 3D print a crap ton of parts for this thing just to make it the best machine it can be. But, you know, at least the base machine isn't, you know, an afterthought. But I mean, one of the best hobbyist machines out there, the Creality 3, is almost completely, you know, 3D printed in terms of the, you know, the joints and connectors, and that seems to do more than fine. So, oh, I know, right? I'm always someone who prefers metal when you can take it, but plastic definitely has its uses. Okay, so the instructions say that with this portion forward, I really wish I had an overhead cam to kind of help a little bit, but essentially just taking them and assembling the two posts in with the screws. So now that I found the large posts, I need to find my screws. And here they are. And they're labeled nice. Okay. Yeah, this is definitely a kit meant for someone who isn't really exposed to a lot of hardware and wouldn't want to fiddle with that. So it's perfect for any beginner, honestly. It's wonderful. Oh, and the washers are even pre-assembled. So it says literally just grab it out of the box, do the single action with it. See if I got the right bit. Do a single action and just assemble it. So that's pretty welcome, honestly. Make assembling this a dream. Pretty sure even my sister or my wife could put this together. Flip it on the side. Okay, so the picture has the long part above it. Oh, so I grabbed the M5 by 35 with washers, and I needed the M5 by 45. Read the instructions. So just insert the screws in the base so they stick through. Find the rod, position it appropriately, and away we go. Make sure not to tighten one screw before the other one is seated. So once they're both seated and mostly torqued, then just do a final tightening. Alright, it's a little bit better. Apologize for any extra noise. This room was originally an enclosed deck, so it's not attached to the rest of the house's AC, so the sun will beat down on it all day. It sits closed because my computers are in here, so that we don't let the kids in, and it just builds up heat, so when I come home it's pretty warm. But I mean, what are you going to do? I just bought a small gate so that the kids won't get in it as much, so we can leave it open before I come home so it won't be as warm. So apologize for sweating. Moving on, this is to have the holes bottom here. Once again, take your screws, push them through the bottom. And thread them in. I like where they put the control box. So the controller is right here. It appears to have a small fan, but is laid out in a way that it's still, somewhat accessible. It has a micro USB? No, mini USB, I think. Not the one that the old cell phones used to use. It's the chunkier one. But I mean, that's fine. But the SD card appears to be a lot more accessible for printing. I'm going to do some printing with the SD card, but I'm probably going to switch over to Octoprint, so I'll have a guide for each one of those as well. Alright. While I'm at it, I'm going to tighten up all of the screws and make sure that the factory screws are also tight. So for 3D printing and any motion system whatsoever, rigidity is pretty important. So you don't want any looseness in your system, because the looser it is, the more likely it is that you'll get printing artifacts and you'll just have all sorts of problems. So the more rigid the frame and the more isolated it is from the ground and from anything else, the better your prints will be. The better your milling will be if you're doing CNC work, the better art you'll do, the better your camera will be when you record if it's isolated from the rest of your components, but yet the camera, the microphone, anything else you have set up on it is rigid, so it doesn't create vibrations that are shown on the camera. Very important. And I have already, unless it's on purpose, okay, I have already spotted a problem. So the screws for the bed appear to be bent, very bent, like way bent. Let's get this from the camera. So we may have to straighten that out, or we might not. We'll find out. Step 2 is to attach the LCD and attach the power supply. So one thing that's critical with this step is to make sure to select the right power settings. So I am in the US. Means I need to have the 110 volts, since we Americans like wasting electricity on nothing. That's our style. Okay, so it wants me to choose two M5x8s a piece. This time I'm going to read. These are M4s, M4x18. M5x8. Oh, so apparently the M5x8s don't go on step 2. There's another screw that's not listed. I'm going to bet these are the M5x35s from before. So if you ever run across that problem, it's not the it's not you. Also, the colors don't match. Pretty much just use whatever they wanted. So it just looks like the power supply is a bit suspended, which is fine because that doesn't crush the XT60 connector. So I'm gonna have to do a quick check once it's all assembled to make sure that this is the genuine XT60, since there were Ender 3s that were shipping without the genuine ones, and they were heating up and causing problems. So I kind of don't want to light it on fire, so I'm just gonna have to make sure to check that. Okay, that's nice and solid. Now we can connect the LCD wherever we find it. So the LCD is just wrapped in some nice anti-static packaging. Good touch. I mean, the chances of something like that happening aren't terribly high, especially since the whole thing's packed in ESD foam. That's why it's gray. It has some form of carbon, probably graphite mixed in. But nice to see. So 2 screws, little stubby variety. And this goes on the same side as the power supply. So it looks like it lines up right there and goes into 2 holes that are threaded in the base of the 20x20 frame. And finish it off with a wrench. Awesome. Starting to look like a piece of electronics. So next step is to attach the Z end switch. Take a look around, see where the heck that's hiding. And it is in the bag along with some extra filament. So here we have just 2 T-slot nuts on it, and all you need to do is slide it down on the side opposite with the L portion of it facing the front. So the instructions, even though they've gotten some parts of it wrong, like not mentioning the extra screws for the power supply, these instructions are definitely a lot better than the pretty much all in Chinese versions with poor pictures that weren't actually like, art. They weren't, drawn and carefully created. They were just like, here's what it looks like before. Here's what it looks like after on an actual product, which is a lot less easy to distinguish from, as well as not being printed to a very high quality. So move it in, bump it down until the little tab rests there. Sit at the bottom and just tighten it down. Alright, so next step is to attach the Z-axis stepper motor to its Z-axis threaded rod with a coupler. So in the box, we have one coupler attached to the Z-axis, and then we have threaded rod, which is protected in yellow condoms of some kind. That's a good touch. So the instructions say to just throw it in, and there are already 2 screws in here, so all we need to do Great. So I only need to tighten down the top one since the bottom one is affixed to the shaft. This isn't my particular favorite implementation. I would have much rather had a threaded rod that was already added to the stepper motor itself. So instead of a weak connection, again, that reduces rigidity. I'd much rather have just one continuously as part of the stator. Whatever part rotates on the inside of these stepper motors. I'd very much prefer to have it there. But it makes it cheaper to do it like this, which means that they can deliver it at this price point. So it's got that going for it. And I am to attach it with the two M4x18 screws on either side. On the back? Yep, on the back. These screws just sneak in right past it. Perfect. Okay, now let's flip over to the back side of the instructions. Great. So step 5 is to start assembling. Show this. So step 5 is to start assembling the X-gantry. So it's the part that hooks into across here and it hooks into this portion here as well. Here it is. Has an integrated X bump sensor, the extruder, which looks much better than the original one here, but we will be upgrading this to the new extruder in the future as well. That really has a very good handle on flexible filaments. So pretty proud of that one. Video on that. And yeah. So it's telling me that I need 2 pieces of a M4x16, and those are what I will use to assemble it to the X-bar. So the X-bar is the one that has the multiple oddly spaced holes in it, not the one that has 2 evenly spaced holes on both sides, like this one. So the one in front is the top bar, the one here is the X-axis bar. And now we play my favorite game of where is the Allen key? Okay, great. So to assemble this, what you need to do is pick up the top bar. So there is a counterboard here that goes around this head here. So the counterboard goes on it. The screws are placed. And I really wish I had overhead cam. The screws are placed in these tools here on the inside, and you put the Allen key through to screw them in. So what I'm going to do is put both of the screws in, so they're dangling in space. Then line up the bar. Sneak it past the X-axis sensor here. That's also important. Make sure you don't smash that up on the way in. And then now that it's mostly in place, start trying to find that hole. There. That was easy. So now it's time to install the other piece of the gantry. So it's alright. So now they want us to add in the belt that goes around it. So there was one pre-wound belt in here somewhere. So they want to wind it and here. And for the instruction, they want the two ends here, the two little tabs, to be in the front. To meet on the bottom. Okay, there we go. Like this. So face in the front, looks like that. Alright, so now we are going to assemble the gantry. So first item on the list is to find this wire here. So you want to install the gantry on the opposite side of the extruder motor, so that the extruder kind of sits on the side and to the back, whereas the gantry, this guy here, sits on the front. And just kind of snake it through. Come on. There we go. So you should have a very firm grasp on this piece. If it's loose, tighten something up. They should have eccentric bolts in here, so you should be able to raise it up and down and to really clamp down the plate. Tight, but not too tight. Because again, rigidity. It's so important. And then I'm just going to take time and loop in those two ends there. Moves it away from me. Alright. Probably not the right thing to do, but I don't want to have the cable screw. Okay. Take this end, put it like this. Want it like that, and put in the other M4 by 16 screws, which are the same ones with the If anybody knows what the bed type is in the comments, I'd love to know. I think it's a PEI with a kind of a fiberglass mix. Not sure. Just tighten up the two screws in the end of the gantry. So here's I put it on backwards. So you want the two rollers to be on the outside of the machine and the one roller to be on the inside of the machine. There will be a countersink in the bar itself that will let you know that you made the wrong choice. Countersink, the screw that you're going to want to put that countersink in. Scratch that and reverse it. The countersink that the screw is going to be able to fit in. Something that I think I'd really like to see would be to have a single Z-axis motor that would have two belted lead screws. So that way they could have a Z-axis on both sides to make sure that it doesn't weeble wobble back and forth. but yet it only requires one motor, so you don't have to synchronize between the two, which is a problem that has been experienced on quite a few other machines that have dual Z-axes off the same motor. Either there's not enough torque, or the two drivers that they use to provide enough torque get out of sync, and that causes issues with the prints with the axis going all wonky. So unfortunately, there's been a bit of a continuity break here. My camera, unfortunately, it's a Sony Alpha 6300 and it has a 30-minute restriction on the amount of time that you can record in sync go. So it didn't beep at me when it was done, it just kind of didn't do it. So unfortunately, we missed putting the rest of the gantry together. So I'd like to just go over that now. What it is the idler is added. So these are two of T-slot nuts. They have to loosen up slightly, slide down the channel, and then tighten back up so you get a grip on it. You want to make sure that your belts are tight, but not terribly tight. It's kind of an art. We'll probably have to adjust it as we get it running just to make sure that it works properly. And I think the only other item was loosening up the Z axis nuts here. Loosening up the Z-axis screws on the top to just give a little bit of play, putting it on the Z-axis, and then putting on the X-gantry here and the Z-gantry that moves up and down and across, and then placing the top piece on and putting in the M5x25 screws in the top. That's pretty much all we missed, and we can start from there. So I was just finishing up torquing the top actually when I thought to go check. So just give these guys a final torque and we'll keep down. For reference, the steps that I missed in the instructions are step 8, step 9, and right now I'm finishing up step 10. Great. The rest of step 10 is to put these two plastic covers in the side just to make it look pretty. It's a nice touch. Makes it look a lot more professional. They just go down the centerpiece and sit there. Again, really sorry for missing all that footage. Alright, step 11 is to assemble the spool holder. So it's just this injection molded piece of plastic here, as well as on here. So it just really just assembles through. There's a nut here as well, I'm assuming. Put that on the back, tighten it down, and then two screws go through here. These will be the remaining two short and stubby M5 by 5. So these ones here. And then they go on these T-nuts. So you can move it around as you feel like. So just insert the screws to the bottom so that they're hanging freely. Put the T-nuts on. Spin them on kind of tight so that they're not going to fall off, but yet they're not too tight that they're not going to move. Because you need play in them to get it to slide in the channel, but you need them to not be so tight or so loose that they fall off. And then, once we find the right key, we tighten them down. And nearly drop it on the ground. There we go. So it looks like it faces the back, which makes sense because the extruder's on the back. Yep. So that's kind of the problem. They need to be loose enough to grab into the channel. It's again, sorry for all the road noise. I live near a road. I have to have the windows open so I don't overheat in here, as you can see. There we go. There. Got it loose enough to turn, and then it gets stuck on the channel, and then it tightens up. Easy peasy. Great. Step 12 is hooking up all the cables. So hopefully this should be fairly straightforward. And I do realize I actually missed a step from before. So there are these little pneumatic fittings. One pneumatic fitting needs to go into the end of the extruder. So that goes at the end of the cold end, and then we're going to plug this end into it later. But for right now, I am going to connect all the wires. Okay, so they are all clearly labeled. There's the X, E for extruder, X for the X end stop. So for clarity, Y is the direction that the bed moves, this direction. X is this direction, left to right, and then Z is up and down in this orientation. One more thing to note, you never want to disconnect or connect motor wires while it's powered, especially while the motor is powered. So don't do it when your machine is on, but definitely don't do it when you're sending commands to your machine. The ribbon cable in front here, which I'm going to snake through, is for the LCD, I believe. One of the several for the LCD by the looks of it. We'll connect it to one of them and see how it goes. Doesn't specify here. So the Y-axis motor and end stop is already connected to the control board, so you don't need to worry about hooking that up. It's already done for you. Okay. So rolling everything forward, I'm just doing a sanity check here. I have my extruder plugged in, I have my X-axis plugged in, I have my X-axis limit switch plugged in, I have the extruder is always plugged in, the bed is always plugged in, the Y-axis is plugged in, the Y-axis limit switch is plugged in, the Z-axis is plugged in, and the Z-axis limit switch is plugged in. The main power is connected by this XT60 connector that I'll have to take a look at to see if it's legit or not. So we'll find out. But otherwise, everything looks to be good to go. taking a look for any instructions on how to set up the LCD and how to hook it up, but it doesn't look like. Okay. So it does look like the cable does have a specified home. So in this orientation, it will be the farthest one to your left. EXP 3. Oh yeah. Always wanted to do that. And by always wanted to, I mean I always wanted to do it and record it. But it looks like we're done. All we need to do is power it up, plug it in. Strike that, reverse it. So just hunt for a power cord, and we'll see how it goes. So this assembly was a bit more complicated than the CR10 assembly that I did. When I had it, this entire thing was pretty much assembled. All I had to do was just throw on the base and away I went. It was a bit longer, but not a big deal. If you're worried about being able to assemble it the first time, I'd say don't be. As long as you can follow instructions, I think it'll be okay. Now we're plugged in. One more verification for the 115 volt. The switch. Voila. So our temperature sensors are reading 27 degrees Celsius. Makes sense. There's a slight bit warm in here. We are looking pretty good for everything else. So that means both of our thermistors are plugged in for the bed and for the extruder. So there's just a couple more things that we need to take care of, and we should be good. One of which is this. Damn it. Alright, so I goofed up a little bit. I'm going to take off the top, snake this back inside of the frame here, and then put the top back on. Should be pretty simple, take me 5 minutes. And click. Alright. So now that we've taken care of all of the little wiring, just time for some housekeeping. So first, plug in your PTFE tubing that will be used to guide our filament from the extruder gear here down to the hot end. 2, it has a built-in wire retention feature here that will escort the cables from as it raises and lowers. I really prefer it to be more like that. That's just me. Third, if you can, just try to zip tie stuff to keep it out of the way. So it does come with a couple zip ties. I'm going to use them to tie back the extruder cable to the rest of the wires, really. Try to organize those cables. And now we are going to work on tightening the belts. So this is a loose belt. It should not be this way. You can't get any power driven that way. So what we need to do, pretty simple. Find the right Allen key. Loosen up these nuts. So there's 4. Ever so slightly. play a note on it, they're probably tight enough. Much better. Hopefully you can hear that. Same thing goes for the one up above. So I did try to tighten it before, but it's still pretty loose. Loosen the screws. Pull it out, stretching the belt. Tighten it down. Probably not tight enough. Same strategy. So that has a nice ring to it too. As for all the goodies that come in the bag that we didn't assemble before, we get a scraper, a nips, all sorts of Allen keys that you use for assembly. It's pretty good selection, so you won't need a tool for it. We get an SD card reader that has a USB adapter on one end and the SD card itself. I'm assuming there were some files on it. Also, we get a spare pneumatic connector for the Bowden tube, a spare nozzle, and then 3 of these little plastic clips that allow you to force the pneumatic connector up the whole time so there isn't any extra slack from the PTFE pulling in and out. We get a small screwdriver, a nozzle clearing, I don't know, some nozzle clearing device, wire? Nozzle clearing wire, that's what it is. 2 wrenches that you can use to secure a lot of the nuts and bolts that are already applied that we didn't have to assemble in our assembly. Some zip ties, an additional nut just in case one was lost or you lose it somewhere, it wasn't there in the first place, and a 100-gram roll of what I assume is PLA. So with that, we are going to get our first level underway. We're going to take a look at everything else. I think I have most of the machine picked up and ready to go, but let's see how it goes. Well, that completes our unboxing and assembly. So now the machine is fully assembled. It hasn't been calibrated, it hasn't been tuned or anything like that. That'll be a video following this one. I'm going to start recording it soon, but that's all I got for the unboxing. So if you like the video, hit like, get subscribed so you can see the initial first setup. I'm also planning on doing a back to basics series for beginners and for even advanced users to try to get the most out of the machine. I was really impressed with the quality prints that came out of the CR10, especially at the price point that it was at for the size it has, and I'm really looking forward to see what I can get out of this machine. So stay tuned. Thanks for watching. Hasta la bye.